This problem says, what is the limiting reactant? We're given this reaction and it appears to be unbalanced. So the first step would be to balance the reaction. Let's look and see. We have one magnesium on the reactant side and one on the products. That looks good. The NO3, that is a polyatomic ion, so we can look at it as a whole unit. And there's two NO3s on the reactant side, but only one on the product side. So let's put a 2 coefficient in front of the LiNO3 to balance the number of NO3 polyatomic ions. But now that makes 2 lithiums in the product side, so let's add a 2 coefficient in front of the lithium to make 2 on the reactant side. And we've balanced the reaction. You can write out the number of each element on each side if you would like to as well to verify that it's fully balanced. From here, it looks like that this is the number of moles that's given for this reactant and the 3.40 grams is given for the lithium. So assuming that that's the case, the way that I like to do a limiting reactant problem, I like to pick one of the products and to convert to that amount of product to compare and see which one of my reactants produces less product, and that would be the limiting reactant. So we could pick either one of our products to convert to. I'll choose to convert to the magnesium just to pick one, and also because it would have an easier molar mass to find. So let's start with the 0.0768 moles of MgNO3 2. So we're currently in moles of a reactant, and to convert to moles of a product, we can use the molar coefficient in the balanced reaction. So to cancel out the unit of moles of MgNO3 I'll put that unit in the denominator. And the unit that I want to convert to is moles of magnesium. And remember that the molar ratio in the balanced reaction can only convert from moles of one thing to moles of another thing. So there we go. And now we use the coefficients as our numbers. When there's not a coefficient written, it would be a 1. So let's grab a 1 from there and a 1 for the magnesium. From here, we could convert from moles of magnesium into grams of magnesium. That would be a typical step. But the question isn't actually asking us for how much of the product that is produced. So we can go ahead and just convert both of our reactants to moles of magnesium. So since it's a 1-to-1, it would just be the same number, 0.0768 moles of magnesium. Now let's take the 3.4 grams, and that is of the lithium. And again, before we convert to moles of magnesium, we need to do a step of taking this. They gave us last time moles, so we didn't have to do the step of converting from grams to moles. But this time we have to do a step of converting from grams to moles because we can only use the coefficients to convert from moles to moles. So to convert from grams of lithium to moles of lithium, let's grab the molar mass of lithium. So the molar mass is 6.94 grams per mole. So we'll put the unit of grams in the denominator so it cancels. The unit of moles on the top, since that's what we want to convert to. And the molar mass number always goes with the grams because it means 6.94. It means the molar mass is the number of grams in 1 mole. So then once we've converted to moles of lithium, this canceled out the unit of grams, and now we're at moles of lithium. And we can convert from moles of lithium to moles of magnesium. So putting moles of lithium in the denominator, because that's what we want to cancel out. Moles of magnesium on the top, since that's what we want to convert to. And the numbers, again, follow the units. The 2 goes in front of the moles of lithium, and a 1 goes in front of moles of magnesium. So then, grabbing my calculator, I take my 3.4, divide it by the numbers on the bottom, 6.94 divided by 2, and we don't have to deal with the ones because it doesn't change anything. That leaves us with 0.2449, etc. moles of magnesium. So again, the rule is that the reactant that produces less product is the limiting reactant. So since 0.0768 is smaller than 0.2449, that means that the magnesium nitrate, the MgNO32, this is the reactant that produced less product, so that is the limiting reactant. Keep in mind that a product can never be a limiting reactant. Only reactants can be limiting reactants, so you'll have to choose out of the options of the reactants. So I hope this video was helpful for you. If it was, please like the video and share with anybody who you think might find this information useful. Thanks for watching.